Now, this book is the science book of class 9. First chapter we can see over here. In the middle stage, science invited you to be curious and observe the world closely, to ask questions, to find out how things work. So when you are moving from the middle school to the secondary stage, now you have to do deep exploration. That is very important. And that is the name of your book, Exploration, where you are going to explore more carefully and find out scientific facts, scientific ideas. Now let us see over here how to go about it. The natural world is complex, and studying it in full detail is often impossible. What you have to do is you have to go bits and bits and you have to assimilate the concepts. Okay? Like over here, see the first example, a cricket shot. Okay, a cricket shot is said when you are going to make a model of this type of thing, that you are thinking of a cricket ball being hit for six. There is a sixer being, is the play, is the shot. Now, you want to make a simple model of it. How you will focus, what key points you will be focusing on. The basic things will be about the mass of the ball, speed, direction in which it is going. Now, this other unimportant, I'll say less important, is the brand of the bat, color of the bat, what amount of grass is there. Of course, it affects to some extent the game. Now here, simplifying the stars, see this part. Science often begins by ignoring details, because at times we see that scientists, they have ignored the details which they have suddenly focused on but previously ignored. We remember the apple from which Newton gave its law of gravity. So, was it that Newton was seeing an apple falling for the first time? Not exactly, but it clicked him in that manner for the first time. So, when physicists like Meghnad Shah studied the light from stars, he did not try to model every atom, every reaction, or every movement inside the star. But what did he do? He treated the matter in the star as a hot gas, ignored many complex processes, and focused on what he was working. That is, focused on the temperature, pressure, and how atoms formed ions. This simplification allowed him to explain how the color of stars is deeply connected to the temperature. That means it depends on temperature. So when you see any scientific process or you are doing any examination, you have to focus on the more important facts, the more important observations, and learn to exclude the observations which are not in context of your research. So Meghnad Shah discover this person who he is. He is an Indian. So you have to meet Indian scientist over here also. You'll get the chance to explore science, see science in the eyes of our Indian scientist. Now, for here you can see, suppose you ride a bicycle from your school to home. You want to model the time it takes to go home to school. What details you need, what you can ignore, and what you can focus on. So many words that we use in everyday life, such as work, force, cell, reaction, they have specific meaning in science. So when you represent anything in science, you can no more be casual. You have to know the significance of each and every term. Quantities like mass, velocity, force, electric current, they have symbol. Now you cannot represent mass by anything. You can represent it by small m, velocity by small v, force by capital F, and electric current by capital I. So these are the symbols that is in association with these parameters, these quantities. So next, moving on, we can see what is happening here. We have to see how to use mathematics in science. For example, when you describe a motion, describing a motion using these quantities, say distance, time, velocity, you need mathematical expressions, you need calculations. So science involves maths as well. So we integrate almost everything, like the powerful language of thinking. So language is equally important. Symbols are important. Mathematics, where you need to include the calculations, are important. So how can you exclude other subjects from science? They are all integrated. Now, we know that speed of light is denoted by c. Some of the students say, ma'am, why can't we denote the speed of light like v, velocity? So we say, no, v is the velocity of a moving object, and you write the speed of light to be c. But why is it so? Did it come to your mind? Why? The symbol C comes from the Latin word celeritas, meaning speed. Celeritas is a Latin word. It's a Latin word. Celeritas, meaning speed. Today, the speed of light is one of the physical constants, and it is taken as 299792458 meter per second. This is the exact value. And you know what? We take it as 3 into 10 to the power of 8 meter per second, because the moment you say 2.997 and all these things, that means you give it in the form of 10 to the power of 8, then in that case, this value is taken close to 3. So you can say it is 3 into 10 to the power of 8 meter per second for that reason. Now, ready to go beyond? See, this news, I think most of you know what has happened, that a passenger aircraft ran out of fuel mid-flight and it had an emergency landing. Now the question arises, when the stats are checked before the flight, then how come this situation? See, the flight actually needed 22300 kg fuel in total. So what happened? The ground crew miscalculated the fuel required, and they used the density of the fuel in pound per liter. So what happened? It was taken in pound per liter instead of kilogram per liter, not in kg per liter. And so a variation of 15,000 liters occurred. It was a shortage of 15,000 liters, for which the flight was actually emergency landed. So this situation arose because of this miscalculation. Science is about calculation. Science is about unit. And so the importance of using SI unit, standard unit. Had it been used in kg per liter, the density, the SI unit would have been used, then in that case, this would not have happened. Now, we'll not judge the situation more, because that's a controversial situation. But yes, we should keep in mind the importance of units in science. Now, the threads of curiosity. Why kilogram is used everywhere? Just think, if we would have used different units, if you would have gone to the potato shop, vegetable shop, and you have said, give me 1 mole of potato, the shopkeeper either would have given you a blank look, or if you would have irritated, would have been given you 2 3, you know what type of situation. So what happens is, you need a common unit in order to buy things everywhere. So for rice, vegetables and all these things, we use kilogram. Okay, now thankfully we have this type of measurement. We have standard measurement, so we can ignore confusion everywhere. Standard units are important. Why? Because they allow scientific units, scientific results to be compared and ensure fairness in daily life and trade. This is the importance of SI unit. This is the importance of SI units. So, what is the full term? I mean, abbreviation is SI. What is the full form? Standard unit. Okay, it is the standard unit. So, for density, what we got? Kg per liter. And for mass, what did we get? We got kilogram. As observations are repeated, measurements refined, and ideas tested through experiments, now we can organize our understanding of the world in a systematic way. Science is about organizing things. Science is about making things systematic. Now, we have heard three things. One is law, the other is theory, and the third is principle. We at times become very casual and we use these terms like law, theory, principle. They almost mean the same. They actually don't mean the same. Law is the regular pattern observed in nature, often expressed using often expressed using words or mathematical relationships. That is a law. Okay. So what is it? The key word is the regular pattern observed in nature. That is the law. Like Newton's laws of motion. Okay, that is a law. Explains why the jerk is felt when suddenly a vehicle stops or bus stops. Theory is what? It's one step forward. It's a step further and provides what? Explanation of why those patterns occur. So theory is the explanation to the laws. Theory is explanation to the laws. They are the explanation to laws. So that is the difference between a law and a theory. And what is principle then? They are the broad ideas that help us make sense in a given situation. So, like principle of conservation of energy, you are applying it to a wider aspect, right? So, we know that we can evolve a law to a theory and we can integrate various observations and we can get a principle. So, we can evolve science from law to a principle, right? So do remember that in science, a theory does not mean a guess or an untested idea. So in science, a theory does not mean a guess. It is an explanation based on careful testing and critical examination. So a theory is an explanation based on careful testing and critical examination. Okay, so that I told you difference between law, theory, and principle. Next, what are the predictions? Science is about predictions also. Not always, you cannot predict a theory, but yes, there are predictions in science where suppose we always say, suppose the situation is this, suppose the mass is this, if we assume the ball is moving in this direction. So there are assumptions, there are predictions. Science allow to do this. They allow us to anticipate what will happen under a new or different condition before we can perform an experiment, right? And this gives rise to new discoveries. This gives rise to limitations and new discoveries. Always remember one thing, that when scientists re-examine their assumptions, their models or measurements, we get new explorations. That means a scientist gives his or her observation, and based on those observations, other scientists can work. That means if we don't get limitations, then we cannot get explorations in future. So often students ask, ma'am, what is the utility of this theory if it has so many limitations and no more we are following it? I will always say, dear, do not forget the contribution of the scientists that gave you the threshold of exploration. So, good scientific questions are always provoking you to think more. Suppose Varsha told her friend Meghna that it will rain this afternoon. It happens, no? At times we say, okay, today it is going to rain. How did we come to know that? Did we dream about it? How? You'll say, ma'am, why not weather forecast? So if it is weather forecast, how did the people over there could forecast the weather? Now here Varsha is not doing that work. What did Varsha say? Look, the clouds are dark. Clouds look dark. Now Meghna could have asked several questions or may have asked. Just see what type of questions Meghna could have asked or may have asked, right? What was the condition of the sky when it rained the last time? Obviously, what is going on in the mind of Meghna? She is trying to follow the pattern. If the condition of the sky today is dark, so last time when it rained, was it dark that time too? What is the humidity today? Now, at times we know that when it is raining, when you are predicting, just see at the sky, it's going to rain. You might have seen your mother running to the terrace or running to the balcony to take the clothes which they have given for drying up. Okay, so now what it happens? What does your mother see actually? The color of the sky, the clouds, dark clouds. Your mother might have felt some cool breeze, might have felt the humid weather. So that's why the questions can be, what is the humidity today? Is it similar to that it was the last day when it rained? Was it 80% or 85%, I will say, humidity the last time when it rained as it is today? That means the humid climate, was it the previous time also when it rained? So these are what? These are interconnections of observation. They are interconnections of observations. So science is about interconnections. Science is about interlinking, is about following a pattern. So this is the pattern that is talked about. Even the most successful scientific theories have limits. So, if a scientific theory has limitations, Dalton's atomic theory has limitations. So, does it mean Dalton's atomic theory is not important? Of course, it's important. That is the base of the structure of atom. So, if it has limitations, it is for this reason that new conditions are explored. New things are coming up. You can work on the limitations. You can work on the limitations to give new scientific theories. So no scientific theory is ever final. You cannot say this is a finishing line and this is all done and dusted. No, dear. This is a theory which may have limitations later on, which may have further work, explorations later on. You never know. Checking viral claims on social media. You people are so fond of social media. You have seen so many reels talking about food should not be eaten during eclipse. अभी तो ग्रहण है, ग्रहण पे खाना नहीं खाते हैं. Why, dear? Why can't you have food during eclipse? What does science say? So now this proof comes from asking simple scientific questions. So question. You may actually irritate people, I know, when you question, but asking question is very good habit, I will say. Please maintain the decency in asking questions. Maintain the respect of the individual to whom you are asking the question, be it your parent or your teacher or your friend, but do ask question. An eclipse is just a play of shadow, isn't it? So, does it mean that if you keep a food under the shade, it will get affected? It will become stale? So, does temperature change the food quality? Does temperature change during the eclipse? This you can, of course, observe the physical changes, the weather changes during eclipse. You can relate it to the quality of the food, you can relate it to the changes occurring in the food, and then you can conclude. And you will, of course, conclude that no physical, chemical, or biological mechanism supports such a claim that you cannot eat during the eclipse. So make your parents understand कि कुछ नहीं होता है. अगर होता तो आप अगर फूड को शेड में रखते तो तब भी तो हम खा नहीं पाते, right? So a helpful strategy is to first understand the situation being studied, the situation which you are studying. Suppose I am studying about the eclipse only. Suppose I am studying about the cricket ball only. So identify the quantities that matter. Finally, make a rough estimate to check whether an answer makes sense. That is how you will do practical also in science. You will note down your observations. You will, as per the experiment, you will write your inference as per your observation. That's why in your practical, you have experiments. You have observations based on your experiments, and based on your observations, you have your inferences. So, your inference. So, science values careful reasoning, perhaps much more than accurate calculations. Reasoning quality is something which is of scientific temperament. How much rice would feed a family of 4 for a month? Now, having this type of estimation, you go to the marketplaces, see the price of the material, see the local price, vary the price, ask your friend who stays somewhere else in some other state, and you talk about the price, compare the price over there. Now, when you see your mother cooks food, or maybe anyone, why your mother? It can be your father, it can be your brother, you yourself cooking food. Now, remember that when the food is getting cooked, what happens is the person who is cooking the food, they have an estimate how much of the quantity is required to feed, say, 2%, 3%, or 4%. This is a scientific temperament, and this comes with experience, with observation skill, right? An average adult needs about 2000 to 2500 kilocalorie per day. So find out how many calories 100 gram of uncooked rice provides when cooked, and use this to estimate the daily requirement. So when you eat, calculate your calories. Nowadays, you have apps, you have digital watches everywhere calculating your calories, your number of steps counted. So you can check your health as well. That is also reasoning and scientific skill. Okay. So next, estimate how many liters of air you breathe in one day. Start by estimating how many breaths you take per minute and the volume of one breath. right? So what you need to do, how many liters of air you breathe in one day? This is the requirement. This is the requirement to do the calculation. How will you start with? How many breath you take per minute? One day में जाना है, so उससे पहले talk about minute and volume of one breath in that 1 minute. So let us see. At rest, we take about 12 to 15 breaths a minute. And there are 60 into 24 minutes a day. Of course, so you have 24 hours, 60 minutes in each hour. So you have this many minutes a day. So we take roughly 18 to 22,000 breaths, about 20,000 breaths a day. So there is not an exact answer for this. The answer has a range. It's an estimation. Science is about estimating. So we also need to find. So you need some estimation. Suppose you are cooking rice and you want to feed 4% and by mistake you are left with rice, cooked rice, say almost 1 person can have a complete meal. That means you have estimation close to the exact need, but you are little beyond it. And suppose you are required to cook for 4 and you cook for 8% or 7%, that is too much beyond your estimation, right? You need to work on it, work on your observation and your estimation skills. So over here you see that, okay, we also need to find the volume of air in one breath. Now, one way to estimate this is to think that it takes about 4 to 5 breaths to fill a typical rubber party balloon. You use balloons during birthday parties, right? So you use 4 to 5 breaths to fill a typical balloon, moderate size, small size, which when inflated has a volume of about say 2 liter. So 4 to 5 breath for 2 liter. So one breath is for say 0.5 liter. Hence we breathe in about 10,000 liters of air a day. So this is again estimation. Now it is hard to see if this estimate is reasonable or not. But if we go back to our previous example, that is balloon 1, one could blow up a balloon in about 20 seconds, right? So maybe we could fill 3 balloons a minute if I take 20 seconds for one balloon, because 60 seconds will make up 1 minute and you can fill almost 3 balloons if you are having this estimate. So multiplying 3 balloon into 2 liter, okay, see this is for per minute, this is for the volume, and for the day we will give you 8640 liter estimation, okay, and it's quite reasonable, close to the estimation 10,000. That is what I said. It doesn't have an exact value. If you do the process by inflating the balloon, you are getting some answer. And if you do by mathematical manner, you are getting some answer. So it is within a range. And the range of say 8,000 to 10,000 is permissible when you are doing an estimation. So if your answer is within 8,000 to 10,000 liter, it's quite permissible. So it's about estimation, no exactness over here. So how does a mask really work? My goodness, I think everyone will remember of COVID-19 pandemic. Yes, not to forget. So solving real problems. You have seen that during this COVID-19 pandemic, or those who have breathing trouble, asthma problem, you can use the mask. And I will suggest all of you to use the surgical mask when you are moving out of your house to protect yourself from the pollution outside. So, understanding how a mask works requires concepts from physics. Why? Because particle motion and electrostatic attraction. Chemistry. Why? Properties of the polymer fibers that is being used here. Biology. Size and behavior of the viruses. Why they cannot enter. You are able to breathe, but the virus is not entering. Is it a magic? It's science. And mathematics. Modeling airflow and filtration efficiency. How much it can actually, filter. You have seen types of filters, right? So different types of filters have different capacity of filtration. So science is about correlation, science is about integration. So here you can see the integration of chemistry, biology, physics, and mathematics. Everything is science, right? Finally, as we have mentioned in every textbook, science is not just a collection of facts, equations, or experiments. It is a human activity shaped by curiosity, creativity, collaboration, and careful questioning. Those who are people who have keen observation skill, scientific manner of thinking, they are mindful as well. So please practice mindfulness in your everyday activity. And here goes your chapter 2 cell, which will be done in some other module. So bye all of you.